In this video for day 1A.7, we're going to be looking at an introduction to what we call proofs in geometry. And so this is going to be a very new topic for you, but it's going to use a lot of skills you've already learned in math. And so we're going to take a look further at how to basically justify our statements when we are trying to go from an original set of given information to what it is we're trying to prove. And I'm going to explain that in a little more detail. So when I have things written on my page, make sure you're writing them down. If you need time at any point in the video to copy anything down, click pause, but make sure you're listening to the video. So in a two-column proof, it's a way of organizing our work into two columns. That's all that means. And this is where the steps of our proof, or the problem that we're solving, are listed out in order on the left, kind of just a way of showing your work. Okay, that's what these steps are. And then the reason for each step is given to the right of each step. So not only do we need to show our work every step of solving the problem, but we need to justify each step. We need to list out the reason why I can do each of those steps. And so we're going to demonstrate that, but first we're going to give you some common properties that are used as reasons in a lot of our proofs. Mathematical properties are just things that allow us to perform certain calculations or to work with certain numbers based on mathematical rules. And so we're going to cover some of those here. And we're going to kind of skip around, so make sure you're paying careful attention to where I write things. We're going to skip these first couple and just start with this one, the addition property of equality, which is this. If we have some equation where some value equals another expression, then if I add the same thing to both sides, it is still true. That's all that means. Adding something to both sides to solve an equation. All right? So that is called our addition property of equality. Now, every property of equality that I use is going to be listed out as POE, property of equality. So this is the addition property of equality, POE. It's an easier, shorter way to write that. So what I'm going to do now is I'm going to list out the next few of these, and I'm going to actually pause my recording and write all of them down and then show you them all at once. You'll want to pause the video and copy them down, and then we can go back and talk about them. All right, these next three, the subtraction POE, let me fix that. Sub-TR. We need to abbreviate subtraction as SUBTR, and I'll explain that more later. Subtraction POE, multiplication POE, property of equality, and division POE. All are just ways we can solve equations and justify the steps to solve an equation. A lot of times we have to subtract the same thing from both sides of an equation. We're using the subtraction property of equality. We're going to need to multiply both sides of an equation by the same thing. Multiplication, property of equality. And division, property of equality, when we divide by something on both sides to cancel something out. Okay, these are all used in solving, and I'm going to write that here. Okay, we use all four of those in solving equations, getting the variable by itself, and that's what we're going to do. Okay? And then we can move on to some more specific ones. I haven't forgotten about these at the top. We'll come back to them. But let's talk about these next couple. Distributive property. Okay, you guys know what that one is. Okay? If we have something like this, A parentheses B plus C, we can multiply both individual parts of that sum or difference and get AB plus AC. That's the distributive property. And notice I wrote property instead of POE because it's not a property of equality, because there is no other distributive property we could use. It's always just prop, so distributive prop. Okay, now these next two are kind of important for what we're going to talk about because they're very similar to each other but not exactly the same. All right, so we're going to talk first about what we call the substitution property, and that is where if two things are equal in any scenario, then one of them, A in this case, just using A and B as generic sets of numbers, can replace the other in any equation. Okay, so if A and B are equal, I can take one out and replace it with something that is equal to it. All right, and that's very similar to what we have here. And so I'm going to write this one out for you. Substitution property. This is why we abbreviate subtraction with a TR at the end, because substitution also starts with SUBT. This is the only property we have, so again, it's not a POE, it's just substitution property. Okay, and lastly, the transitive property. Now, this could be a property of equality. Okay, so I'm going to write this out as trans POE. And it just says this: if A equals B and B equals C, so I've got one thing equal to a second thing, the second thing equal to a third thing, then that first thing, that one thing A, is equal to the third thing C, because it's also equal to B. I can use substitution to get to this property. Okay, I could just replace B with A since they're equal and get that. Okay, these are very similar to each other, and there's different times when you can use them interchangeably and other times you can't, and so we'll talk about that more later. So let's go back up to the top and talk about reflexive property and symmetric property, and these are often confused. Okay, reflexive property is the one we're going to start with, REFL period, and then this is another property of equality, POE, just states this: A equals A. That's it. It's just something is equal to itself. We will use this in certain situations, in proofs. It seems redundant, seems unnecessary to state, but you'll see how we use it actually quite a bit. Then finally, what we have here is the symmetric property. It's another property of equality. Okay, and that says this: if A equals B, then B equals A. That equation is symmetrical. I can flip it around and it's still true. And that's just when anytime I write an equation and I end up with my variable on the right-hand side and I need to flip it back to the left, that allows me to do that. Okay, so we're going to look at some examples in class. Okay, we're going to leave these whole two columns blank, but we're going to jump right into the examples on the next page. So we're going to do an example together that shows us how to do a two-column proof. And this is something that is going to take what you've already been doing with solving equations. Remember, part plus part equals whole and part equals part. Those equations we solved, but now I'm giving you the answer, and we're going to write out an explanation of how we got to that answer, justifying our steps. So the first step in a two-column proof is to always write out the given statement as step one. Okay? I'm not actually going to make a table here. That can be done. You might see examples like that, but for right now, we're just going to list out our steps. Number one is the given line. Okay, we're just going to rewrite that original equation. 5 parentheses x minus 12 parentheses equals 2 parentheses 2x plus 30. We're going to start with our given. That has a reason that goes with it, and what I like to do is come out here to the right and in parentheses give my reason. The only reason I can write that on my paper is that it is given information. So the first reason we write is almost always given. Okay, that's the first thing we're going to write as our reason. Okay, now we're going to move on to step two, and we're going to simplify this doing the first thing we would do to solve this equation. Well, the first thing you're going to do is distribute, but the statement, here's where this is different. The statement line is just going to be the result of the next thing. So we're going to distribute, but I'm going to write the result. Okay, I'm not going to actually show the work. If I wanted to show the work, I'd go up to step one, but I don't want to do that. So I'm going to distribute 5 times x is 5x, and 5 times negative 12 is minus 60. Bring down the equal sign. I'm going to distribute here 2. 2 times 2x is 4x, and 2 times 30 is plus 60. And I used a property from this page. I used the distributive property to simplify that part of my equation. So I'm going to write distributive property as my reason. I'm going to keep going. The next step. Now this is where some of you might do things a little differently than I do. I like to get the variable on one side only first. So what I'm going to do is cancel out this 4x. Well, in order to cancel out the 4x, I would need to subtract it from both sides. Since I'm subtracting 4x from both sides, I'm going to be using the subtraction property of equality. So I'm not going to show that step. If I did, I could kind of write it small here. It's not going to be in this line 3. Line 3 is the result after I subtract. Okay, so if you do this, that's fine. But in proofs, when we're writing a proof of this, I don't need to show that part. What I really need to show is the result. 5x minus 4x is 1x. And then I still have my minus 60 equals, there's no longer an x there, I have plus 60. Okay? So the reason I could get this statement was that I subtracted the same thing from both sides. So that's the subtraction, POE. And then we really just have one step left, because the next step is to cancel out the minus 60 by adding 60 to both sides. And again, if you want to show that, kind of show it between steps 3 and 4. Plus 60, plus 60. You don't have to. These little things I've written in red here, you don't have to do. But we want to write the result. Well, now x is entirely by itself, and this side, 60 plus 60, is 120. And again, the reason for that is that I added the same thing to both sides. So it's the addition, POE, property of equality. Now, what you'll notice is step 4 here is exactly what I was trying to prove. Since this is what I was trying to prove, my proof is done. Notice I did not write the word prove as a reason. And over here where you have room, write this down, please. Prove is not a usable reason, okay? You cannot use the word prove in parentheses as a reason. What we've just given here, okay, this entire column are all reasons. All right? So this is a 2-column proof. All right? And that is what we're trying to prove. So here's what I like to do every time I'm done. I put these 2 little marks, kind of like parallel lines but more slanted. I'll explain what those mean in class, but go ahead and add those in. And that's how you do a 2-column proof. We're going to take a look at the other examples in class. We're going to do a little bit more notes in class this time, because it's really important to do these things together. And so you should have at least this done when you come to class, and we will talk more about proofs then.